So I had you brainstorm the meaning of an angle, and I'm going to give you a different definition. It doesn't mean yours is wrong. But mathematically, we talk about the amount of rotation, which a lot of you had. And then a lot of you had intersecting lines, which was good, things that intersect, which was good. It's just we want to give them specific names. So we call one of them the initial side. We call one of them the terminal side. So for example, if I'm to draw any angle, because of the way I've put the arrow on this angle, it's telling you that for this one, the x-axis is the initial side. The line I drew is the terminal side. And who remembers from last year or the year before, what is the variable that we use to represent an angle? Theta. It is theta. Why theta? What the heck is that? It is a Greek letter. Why do we use a Greek letter? We have English letters. They're great. Why don't we use them?
Because the Greeks invented trigonometry.
Because the Greeks invented trigonometry. Which English letter does theta correspond to? So what's its equivalent in our alphabet? So, X, I heard X, I heard O, I heard T. Anyone want to guess? It's actually a little t. It's a lowercase t, which originally we kind of drew t's like that, and then eventually it kind of curved around. And I like to spell it, not only for the visual people, because I once had a student graduate and go to university thinking it was feta, like the cheese. It's not. It's theta. So please don't tell your university professors it's feta. It just makes me look bad.
Is that the how you spell it?
Theta, yep. T-H-E-T-A, theta.
See why they said it too.
Yeah, feta, not the cheese. Well, what if I had chosen to do an angle the other direction? So what if I had come down here? And let's say these were roughly the same measurement, although I didn't draw that. But let's say, I don't know, this is roughly 45, and let's say I want to do a 45 down below. How can I tell the difference between them if they're both 45 degrees? Well, we call this one a positive angle, and we call the other one a negative angle. So if you see negative 30 degrees, for example, it doesn't mean the value is negative, because we know when we measure something, it's impossible to get a value. All that's telling you is a direction. Positive angles go in what direction?
Right.
Counterclockwise. I'm going to repeat that in case you're a wordy person, you want to write that down. Positive angles go counterclockwise. Positive angles go counterclockwise. Negative angles go clockwise. And we're going to come back and talk about negative angles later on in the unit. There are two different ways to measure angles. That's actually a big fat lie. There's three, but you'll never meet the third system. So in this course, I'll tell you when I'm kind of lying to you just because it doesn't apply to you, but there's actually three ways to measure. The first one is what you've been doing since grade 5, which is degrees. Again, invented by the Mayans, it was great, but the Europeans thought, too many different things to break up into 360. They came up with the system where you take the radius, measure it around, and they called that radians. Radians comes from the radius of a circle.
What's the third?
Thank you for asking. It's called gradients, and you'll meet it if you go on to engineering and need to do really precise measurement. Otherwise, you'll never hear it again. Remember when you started trigonometry in grade 10 and we kept telling you in your calculator, it has to say degrees, it has to say degrees. Check your mode, the mode has to be degrees. And sometimes you got a really weird answer. And we're like, did you check your calculator? What happened was is you were actually putting your calculators into what's called rads or radian mode, and that's why the answers weren't working out. So that's why we were like, degrees, 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 because it mattered then. Now, it's going to matter which system we're working in. Degrees are going to seem really weird at first. It's the equivalent if I said to you, it's 72 degrees outside. What does that mean? So if I said it's 72 degrees outside, It probably means I'm talking in Fahrenheit, because rarely outside would we have 72 degrees Celsius. So the US system seems weird to us because we didn't grow up with it. We don't have a reference point for that. What if I told you 72 is the same as 21 degrees Celsius? Would you know what to wear outside? Because I've given you a reference point. I've given you a reference in your system, Celsius, and I've said that's the same as this over here in Fahrenheit. If we worked in Fahrenheit a lot, you get used to it. You would know what 100 degrees Fahrenheit is like. It's really hot. You would know what 32 degrees Fahrenheit is, which is really cold. So at first, this is going to be really confusing because we have drilled degrees into you, and you can picture 90 degrees. Show me using your hands or arms what's a 90-degree angle. Everyone knows what that looks like. You can visualize. And by the way, I did that for tactile people because they need to do and move to learn, as we talked about on Friday. If I said to you, what's a pi angle? That means nothing to you at this point because you don't know the system. That's what we're going to talk about today and tomorrow, is converting from one system to the other and going from our system to the new system and back and forth. Again, at the beginning, this is going to seem really confusing. The longer we work with it, the easier it's going to become. So here is what's called a rad, which radians are made up of rads. 1 radian is the measure of the angle subtended at the center of the circle by an arc equal in length to the radius of the circle. Got it? Makes total sense? Probably not even one word. Well, that's the official mathy definition. Let me show you with a diagram. So mark where you think about the center of the circle is. We're just estimating. And I want you to draw one radius, any direction. I don't care which way. I'm going to the right because I'm right-handed, I guess. Now imagine we took a piece of string and we measured this radius. And it doesn't matter how big the circle is. I just picked a circle to fit in the space. If we were to measure this radius on a piece of string and then lay it on the circumference, approximately where would that tick mark end? So it ended up being approximately up there. And this is what we did on our paper this morning with the string. It was approximately that distance. And I want you to join that little tick mark back to the center. We do kind of get Pac-Man there. More importantly, we get that the one radian, or one radius I should say, is equal to the other radius because it's a circle, but more importantly, that arc in between is also the same distance. That's the definition of a rad. 1 unit in a rad is one of those string lengths. And if we went around the circle, we should have 6.3-ish radians around a circle. That's the mathematical definition of a radian. It's approximately 58 degrees. Approximately 58 degrees. So I'm now giving you that reference in your system, so now you can start to picture what does 1 rad look like. So 1 rad, 58 degrees. How much is 2 rads? So I heard 3 little mumbles, but no. 116. Using your hands or your arms, turn to someone and show them 116 degrees. So most people did exactly what I expected. They started at 90 and added a little bit, right? Because 90 is a good reference point. You know what 90 looks like. Keep that shape. Show me again what 116 degrees looks like. That's 2 rads. Show me 1 rad. So cut it in half. That's 1 rad. Now you know what 1 rad feels like and what 1 rad looks like. 3 rads. Offer of, I kind of heard it, but not really. 174. Does somebody want to confirm that? Okay. And I'm just going to pause briefly. I'll do this the whole semester, by the way. I don't do the math for you because I always say I'm not your math monkey. So somebody offers, I'll always say, can someone confirm? If you confirm a wrong answer, I will not stop you. So make sure you're confirming, not just agreeing, sure, I don't know. 4 rads. 230, I heard. 232. Can someone confirm? 5 rads. 290 even. That sounds confirmed. And 6 rads. I heard 348. Now, because I'm a color person, I'm going to grab my highlight, and I'm going to highlight over, and I'm going to highlight the little symbols I put here, and make sure you've put them as well. And we were pretty sloppy with you in grade 10 and 11, and we didn't really enforce units, because you only had one system of measurement. We assumed if you put down an angle value, it was degrees. But now there's 2 systems, so you have to be really careful with the units. What's the symbol for degrees? It's the little circle that's like an exponent. What's the symbol for radians? There isn't one. So if you just put down the number 60, I'm going to assume that's radian values. If you want to show me 60 degrees, you have to put the little degree symbol. Okay. Well, let's just draw out what these look like. Again, mark where you think the center of your circle is. And we all need a common starting point, so I'm going to go to the right simply because I'm right-handed. And let's call this 0. And just for our reference, I'm going to put the vertical line, which we know is 90 degrees. And I'm just doing it dotted because I don't want actually this to be part of the radian measure. We're just putting some references. And I'm going to put a dotted line at 180. And a dotted line at 270. And with a partner, so you can either find someone around the room or turn and talk, whatever you prefer, I want you to draw me the 5 lines that represent 1 radian, 2, 3, 4, 5, 6 rads. I guess that would be 6 lines. Okay, so for example, I'll do with the first one for you. We know 1 is approximately 58. So I would probably start by going 45, which we know is halfway. Do I need bigger or smaller? Okay, so I'm estimating approximately where I think 58 is. There is 1 radian measure. I want you to show me all 6 around the circle. The point of that diagram was just to give you a visual reference. So now above you know the degrees, and you know now roughly what 1 rad looks like, what 2 rad looks like, et cetera, et cetera. Again, at the beginning this is going to be confusing because you're not used to it. The more we work with it, the easier it's going to become. So now let's go to the circle where we add the axes. And this is where we took you in trig last year, and we said that you needed to know the 4 different angle values. So we said that this was 0 degrees, and top of the circle is 90. Oh, it's frozen, sorry. Sorry, I wrote a 0 there. And top of the circle is 90 degrees. And the left-hand side is 180 degrees. And the bottom is awesome. And if we come back a full circle, we end up at 360. Now, a couple of things we were doing there that you didn't know last year. Number 1 is make sure you have those degree symbols, which we were kind of iffy on that last year. Now it's really important. The other thing is watch where we put the terminal and the initial angle, or the initial side, I should say, of the angle. The initial side always goes on the positive x-axis. It's just because we need a starting point, so someone decided it's always going to be on this side of the circle. So that will always be your initial side when measuring angles. The other thing is look at the direction that we went. What direction did we go around? Counterclockwise, and that probably seemed maybe weird to you last year because we're so used to things going clockwise. It's because someone decided along the way that the direction counterclockwise is positive. If I wanted to go clockwise, this would not be 270, this would be negative 90. This would be negative 180. The top would be negative 270. It's just we need a reference to know what direction we're going around the circle. Okay, I'm going to switch colors to do rad, so if you're a color person, you might want to switch with me, and I'm specifically going to use 2 new colors to do this. Oh, the little left brains love to switch colors with me. So this is still 0 radians. And you'll notice I put no symbol after that. I didn't put a degree, I put nothing because no symbol means radians. In really, really old textbooks, they would have put a little symbol like this. You can't see that. So it's like a little r with an exponent, but then they stopped doing that because we didn't know, is that a variable? Is that radians? What is that? So this is out. But if you have a really old textbook or an old professor at university, they might sometimes do that little r. Okay, well, let's come all the way around the circle once, because I already told you what the equivalent to a full circle is. What is it in decimal value? This is where we laid out our string and we estimated what is it in decimal value? 6.28 approximately. Okay, so for that, let's work backwards. If a full circle is 6.28 rads, what's half a circle? 3.14. Ooh, is that an important number? Okay, let's use our logic skills. What is the top of the circle? So what's a quarter of a full circle or half of a half circle?
Half a pi.
Okay, and what's that in decimal value? So 3.14 divided by 2.
1.57N079632.
If we rounded to 2, are we okay with 1.57? And that sounded confirmed? Okay, what about the bottom? So 3/4 of a circle, or half a circle plus a quarter of a circle.
4.71.
So close, 4.71. And I'm switching colors and I'm going to red for this specifically. We talked a bit this morning, there's a difference in math about precision. There's times we need to be precise and there's times it doesn't matter. Angle measure is one of those times it really matters. So yes, we can give the decimal values, but that's not really how mathematicians enjoy giving the values. We enjoy using the pi symbol because it's not rounded off. So we say a full circle is 2 pi. 1 circle equals 2 pi. Which is crazy because a pi, like an apple pie, is 1 pi, but then it's 2 pi when you measure it. I know it doesn't make sense. What's half?
Remember, pi for food has an E.
I know.
Pi does not.
What's half a circle if a full circle is 2 pi?
Pi.
Half circle is pi. What's in the middle? So what's a quarter of 2 pi or half of 1 pi? A half pi, and we write that as pi over 2. We call it pi on 2 because we're lazy and we don't want to say over. Pi on 2 is the way we say that, which is half a pi or 0.5 a pi. 3/4 down here. Okay, so a pi plus a quarter or 3/4 of 2 pi. So if you think of it in terms of decimal, this is really 0.5 pi, and this is 1 pi, and this is 2 pi. What do you think would be in the middle down here? 1.5 pi, and how do we write 1.5 as a fraction? 3/2. We call this 3 pi on 2. There are your 4 axes values in radian measure. There's 0, pi on 2, pi, 3 pi on 2, and 2 pi. 0, pi on 2, pi, 3 pi on 2, and 2 pi. Questions on so far on what the heck is a radian? What is it equal in degrees? Why do we need to know this? All right, that's the speech. This is all we're going to do this afternoon, is we're going to convert rads to degrees, and then we're going to go backwards and convert degrees to rads. When you see a method box, that's probably going to be really important. What you don't see on the page is room to do your work. The reason I've done that is twofold. Number one, it wastes way more paper if I leave you space to write the answers. Number two, I specifically want you to do it on a different paper because then when you go back and study, you don't have the answer right in front of you. So it's a good study technique for you to retry these questions later. So grab a piece of paper, and I'm going to say this practically every single day. Get out your notes and a piece of paper. If you're left brain, you probably want the date on it. Remember, the date's always over my shoulder in blue. If you guys reminded me in period 1 to change it. And I always go back to the main heading at the beginning, which was measuring angles. And the reason I would call it that is because that's what it's called on the calendar. If that's not specific enough and you'd rather call it converting rads to degrees, call it whatever makes sense to you. Okay, so title it. If you need the date, put the date. If dates are important to you, don't put it there. I don't title mine because I throw this out when I'm done, so I don't need to. Some people like to write down the question. I don't know if it's necessary because it's in the booklet and later you can match them up, but if you feel you need to write the question, write the question. Now I'm going to ask you this a lot during the semester. I'm going to say, do you want the method first and then do an example, or do you want to see an example and then write the method down?
Method first.
Method first. And sometimes that might change, just depending. Different ways, like different people like different ways. So let's go to the method box. Again, I'm a highlighter. Visual people, we need stuff to stand out. The method is you're going to use the following formula, and I'm putting formula in air quotes because it's not really a formula, it's really just two ratios, so you won't see it on your formula sheet. So you may want to put a little note, not on formula sheet or memorize or need to know, because this is not going to be on your formula sheet because it's not really a formula. All we're doing is setting up two proportions. We're saying that the number of degrees divided by 180 has to be the same ratio as the number of radians divided by pi. And that's just using what we know about circles. We know that 180 is the exact same as pi. Pi radians equals 180 degrees. That's why it's not really a formula, because it's just two ratios we're equalizing to each other. What that means is we can substitute pi for 180 degrees. So how many degrees in pi on 5 rads? Very first question we're going to do this semester. Now, again, I'm a highlighter. So what I always like to do is highlight the key words in questions. And when we get into longer word problems, you're going to enjoy this. For now, I know there's not a lot of words. Humor me. Degrees is important. And pi on 5 is important. And again, pi on 5 is going to look weird to you because you haven't seen it before. What that's telling you is that's the radian measure. So you know it's half a circle divided by 5. So picture half of a circle, roughly chunk it into 5. That's approximately how many degrees this is, and we're going to find out exactly in a second. This might be the easiest thing that we do this entire unit. If pi is in the question, take it out and put 180 in its place. If pi is in the question, take it out, put 180 in its place, because we know those are equivalent. Pi, 180, exact same thing. So I'm going to take our radian measure of pi on 5. I'm going to physically take pi out, and what am I going to plunk down in its place? 180. And then I'm just going to reduce that, because we would never leave a degrees as a fraction. So grab your calc if you can't do that in your head, and do 180 divided by 5. Do I have an offer?
36 degrees.
Do I have confirmation?
Yes.
36 degrees. And if you take half a circle, roughly 180 degrees, and divide it into 5, it's roughly about that measurement. That's how to convert radians to degrees. Example number 2. Four pi on 7. So that means we're taking pi, a half circle, we're chopping it into 7 pieces, and we're taking 4 of them. We're taking a half circle, which is pi, we're chopping that into 7 pieces, and we're keeping 4 of them. All you need to know is you take pi out, and what are we going to put in its place? So I'm keeping the 4, I'm keeping the 7, I'm just shoving that 180 in there. Why did I bracket it? Because I want to show that multiplication by the 4. I don't want to just smush that and put 4, 180. It gets confusing. You can use the little dot if you want for multiplication. Don't use an X. Throw this into your calc top first, so 4 times 180, and then divide by 7 all in one shot. We'll give it to you. I kind of heard a mumble there, but not really an answer. Say it louder. I got
32.86.
10 point. Is that rounded? Okay. Make sure you have your little degree symbol after that, otherwise it's wrong, and it's a half mark off if you forget the degree symbol. I'm going to do this many times a day for the rest of the semester. I'm going to say, show me your thumb. This is, I get this, I totally am understanding. This is I'm kind of getting it, maybe not. This is I don't get it at all, and you can be anywhere in between. You put it high, but you have to put it up, and if everyone puts it up, no one knows where your thumb is. So this is where you don't be afraid to tell me I'm down here. What this tells me is, do I need to re-explain? So show me your thumb after the first two examples. I get it, I kind of get it, I don't get it, any degrees in between. Good. Again, if you put it high, no one will see where your thumb is. It's just for me to figure out. Let's go to example number 3. 2.35 rads. Where is the pi? Does radians have to have pi in it? No, it can be decimal values, and this one happens to be a decimal value. So what do you do if pi is not in the question?
Because you know the measurement of 1 rad, so you could convert it from that, because you know what 1 rad is, and you could divide it with.
The problem with that is I told you 1 rad is approximately 58, and we want it more exact than that. So what you're going to use is this guy right up there. That's it. You're either putting in pi for 180 or you're using that formula, and I'll show you in a second how to use it. So to use the formula, I'm given a radian degree, so I'm going to divide that by pi, because that's our r divided by pi. What I don't know is the degrees, and I'm going to divide that by 180, because degrees goes with 180. So you're either subbing in d or r, you're leaving the other one blank. This now is just a little equation from grade 9, a linear equation. You have to get rid of a division by 180. What's the opposite of dividing d by 180? Multiplying. So I'm going to multiply each side by 180 to get rid of it. So that leaves the d all by itself, which is want. The other side is a calculator question. You're going to do 180 times 2.35 divided by pi. Now, we are mathematicians. This is 40 pre-cal. We use the pi button. We don't punch in 3.14. That's not exact enough. We don't punch in 3.14159. That's not exact enough. If you don't know where the pi button is, ask your neighbor. But there's a pi button, we want to use it. So 180 times 2.35 divided by pi. Let's go to 2 decimal places, since we did the last one to 2. You gotta talk loud. I seriously have old lady ears.
134.65.
Can we confirm that rounded correctly to 2 decimal places? Yep. 134.65. Make sure you got your degree symbol. Questions so far?
Just like an equation question in general, like anytime you put like say x is equal to this, or like like the degrees, if you put degrees equal to 134.6.
Can you flip those sides? Is that what you're asking?
Yeah, or that, or can you, because you already you said it's degrees, do you still have to put that degree in?
I would just in case, because again, it's not me marking every question on your provincial exam.
Yeah.
So just to be clear, I would get in the habit of putting it.
Okay.
Okay, let's go the other way. Let's go degrees to rads. 150 degrees, how many rads is that? Well, turn and talk, and what I want you to do first is estimate with a friend. So what you already know about rads, estimate about how many rads is that. Turn and talk for a minute. But just estimate from what you know now.
Say.
2.6. Tell me logically, where did you come up with that?
From our last,
Explain.
our last example was 134.65.
Okay.
And that was 2.35. So
And this one's a little bit bigger, so you know that's great logic. Anybody use different logic to come up with an estimate? Nobody did it any differently. Okay, well, let's use some logic from what we know about the axes. 0, we start here, and we know the top of the circle is 0.5 pi, and we know this side of the circle is pi. And what's pi as a decimal? 3.14. So we know a half circle is 3.14. Where does 150 lie in relation to a half circle? Less or more? Less, because we know a half circle is 180, and we need slightly less. So it's less than 3.14. Give me an estimate. 2.8, 2.7. So there's just a different way to estimate it. What do? There's no pi in the question. Then use that little formula that we have above. We have a degree, so I'm going to divide it by 180. We do not have a radian, so I'm going to put in r, and I'm going to divide r by pi. Okay, for those of you that are weak in solving equations, I'm going to do this step by step. If you're ahead of me, that's a-okay. I'm going to start with the r. How do we get rid of a division by pi? You multiply by pi. So what I'm going to do is just tuck it in the back. That's where pi goes, is behind the actual number. So I get 150 pi divided by 180. The next step is we need to reduce. Well, automatically we can get rid of the zeros. Mathematically, how did I do that? What did I reduce them both by to just get rid of the zeros? I divided them by 10. So 150 divided by 10, 15. 180 divided by 10 is 18. Now just look at 15 and 18. Do they have a common factor? 3. So let's divide them both by 3. 15 divided by 3. And 18 divided by 3? 6. There's how this is a non-calculator question. That is what we would expect you to be able to do without a calculator, is reduce numbers like that. If it's crazy numbers, it'll be calculator, but something divisible by 3, divisible by 10 is expected. Now what? That's it. That's the question. We're done. Well, what about the decimal value? Well, do we need to give a decimal value? No, because what do we call this?
Exact.
This is an exact value. Let's make a note of that, exact value. If the question says, state your answer as an exact value, that's where they expect you to stop. If it doesn't say, you can go a step further and get the decimal value, the question is why? What does the decimal value do for us? Okay, so if the question says exact value, you'd stop there. If it doesn't say, you could go one step further and get the decimal. Let's get the decimal just so we can compare to our estimate. So how do you get a decimal value for that? Throw it into your calc. So 5 times pi, divide by 6. Let's see how close our estimate was. 2.63, and we said 2.6, and then 2.7. Nice, nice. Questions so far? Do you understand when you leave your answer like this and when you can give the decimal? If it says exact value, it's exact value. But again, there's no point in giving the decimal, really. So I would just leave it here. Number 5. 225. Is that a degree or is that a rad? It's a degree, so what goes underneath it? What goes on the other side of the formula? What do we not know? R, and it's over pi. Same as the last one. How do I get rid of a division by pi? What's the opposite of dividing something by pi? Multiplying. So I'm just going to tuck it up to the other side and cancel it on the right. Again, mathematically, I've just multiplied each side by pi. This would be something we would expect you to not be able to do in your head. So if you need your calculator to reduce 225 and 180, that's fine. If you can do it in your head, great. Did your math teacher last year show you about frac button on your calculator? Oh, you're going to love this. Okay, punch back in 225 divided by 180, and then just don't touch anything. And then on the left-hand side, you have a math button, and I want you to hit it. And number 1 should say frac, F-R-A-C, and I want you to hit number 1 or hit enter, and you should get 225 divided by 180 frac. Do you see that on your home screen? Hit enter. What just happened? It gives you the fraction back. You don't even have to convert from the decimal. It does all the work for you. What is the radian value that's equal to 225 degrees? 5 pi on 4? Confirm? You may want to make a note so later you understand this is non-calculator for number 4. This is calculator for number 5. So number 4, we would expect you to use that level of math without a calculator. Number 5 would be one we would give you a calculator for. Show me your thumb so far. How you feeling? I'm getting it, kind of getting it, not getting it. Good. Let's go on to number 6. Oh, Lord, we have a negative. Negative scare me. What does a negative mean? Yeah, it just means a different direction. Does that have any impact on converting from degrees to rads? No. Has no difference in the question. If it's in front of the 300, it's going to be in front of your radian measure. It has no difference in this question. Is this a degree or is this a rad? What do we put underneath a degree? On the other side of the formula, what do we not know? And what do we put under an R? Do you see the similarity between example 3 and 4 and 5 and now 6? What's the next step in the 2 previous examples? Move the pi, because we're multiplying to get rid of the division. This would be a non-calc question, so let's work through together. First thing we can do is cross off the zeros. Why? We're dividing it by 10. Now 30 and 18, what can we both divide those by? 2, 3, 6. Well, let's say you didn't know which one, so let's do 3 first. Even if you know it's 6, bear with me, let's do 3. So negative 30 divided by 3, negative 10, and 18 divided by 3. And then when you look at that, it's like, shoot, 10 and 6, what do you know there? We can divide them each by 2. So even if you didn't see at the beginning it could be divided by 6, you're going to catch it here. So now let's divide by 2. Negative 5 pi on 6. On 2, 3, better, 3. 6 divided by 2. If you could go straight from the negative 30 over 18 to negative 5 on 6, great. If you needed a secondary step, great, doesn't matter. You might want to make yourself a note that in this question the negative really is irrelevant. It doesn't change our process at all. It's just a direction.
Zero, keep on saying there's no calculator and calculator. Do you know what's expected? Are we going to actually ever have to do it?
The exam is split into 2 sections. The first hour is calculator. The second 2 hours is non-calc. So that's why I keep letting you know all semester, this is what a calc one looks like, this is what a non-calc, so you'll understand. The last one, find a friend, work by yourself, whatever, give you a couple minutes, try it out. If you prefer to work alone, just check with someone when you're done. Okay, let's talk about it. Usually near the end of the examples, we'll do something like this right now, that I'll say, you tell me what to do. How often do you get to tell teachers what to do? Think about this. So let's focus back as a group. Somebody offer an idea. So just shout it out, whoever's feeling, tell me what to write down.
Negative 420 and 480 degrees.
Now here's the trick with this is I will not stop you if you're wrong. That's your guys' job. So if somebody offers a suggestion, you don't need to go, you're wrong. You just need to very politely correct them, and it's not a big deal. But this is you guys to figure out what's going on. I'm just writing stuff down.
No.
What?
Smack it on the other side of the 420.
Why? Because you told us to. But why? Why did I tell you to do that? Yeah, it could look like a subtraction, right? That's why we don't put pi in the front. It's why we tuck them in the back, because we understand that's multiplication. Okay. Okay. I heard divide by 3, divide by 6. Does it matter which we do? No. If you can do 6 right away, great. If you do 3, you'll eventually get there. So let's do 6.
Minus 7 pi divided by 3. Right?
Yes. Confirmed.
You're correct.
High fives. Show me your thumb.